This is an ornamental light I made some time ago. It's featured in another video which covers lights I've got around the house that I made myself. And tonight I'm going to be showing you how I make one of these. So I'll just turn the power on. It's a fairly low intensity light, it's just designed for decorative use. And it fits in a standard bayonet cap lamp holder, which is the standard UK lamp holder. And this one's unusual from the others in that it's got lights around the side as well, and it's also got little press-on caps over the LEDs, and in keeping with all the others it's got the LEDs in sockets. So I shall show you how this goes together. Now I've got this little bayonet cap to GU10 adapter, and I was wondering if it could actually make, because it looks quite attractive, I wonder if I could take that out and use it as a base for the light, but it depends if I can fit the circuitry in or not. So let's take that to bits to start with. It's not going to come out. Alright, the wire is long enough, and okay. Knife, a suitably robust stabby knife. Let's see if I can get these little push-in pins out. It's the type of connector that they've got little rivets that basically go down. The wire gets tucked in and then the rivet gets pressed in and it holds the wire in place. But they're pressed in quite tightly. So let's see if they come out without too much hassle. These have been pressed in really tightly. Right, I've lifted it a wee bit, so I'll try and get the snips under that now and prise it out. If I close the snips on it, it should just pop. There we go. 1 and 2. Put those aside at the moment. Okay, that looks quite roomy inside. I think that's going to work. So I shall proceed. So the circuit I'm going to be using is going to be very simple. It's going to be a capacitive dropper, as I often use, which means that all these little sockets are going to be, basically they're going to have contacts, and if you poke the LED in, it will be mains voltage. So it's purely because, well, it's the simplest way of doing it. It's not the safest way of doing it. So I'm going to be, in our case it's 240 volt mains. I'm going to be using, say, a 100 nanofarad capacitor, 400 volt, and a standard 1 meg ohm resistor across that as a discharge resistor. That basically means when it's unplugged, you're not going to get a wee tingle by putting your finger over the pins. It's going to be a bridge rectifier, a discrete bridge rectifier, and it's going to have a 1k resistor in series, purely to limit the inrush current, and then it's going to be the LEDs. There's not going to be any smoothing in the LEDs because I'm only going to be using 12, and the combined voltage is so low that it's not really going to show up any noticeable flicker. And it keeps things simpler and removes explodey bits like electrolytic capacitors. So that is going to be the circuit. Very simple. So here are the components I'm going to use. If you're in America, if you're running on 110, 120 volts, you could probably use, whereas this is a 100 nano 400 volt, you could probably use a 220 nano capacitor rated 200 volts. So I'm just going to fold the leads on that capacitor sideways without putting too much strain in the body. I'm going to find my 1 meg ohm resistor, discharge resistor, and I'm going to put that across the capacitor, and I'm going to twist the leads. This is probably going to be a fairly long video, so if you get bored at any point in time if I start doing repetitive things, you can skip forward to get through them, or you can just watch the whole thing. I will be pausing the video maybe at the end, things like when I'm putting resin in and things like that. So I've put that resistor across there, and I'm just going to tack that on with solder. And then crop the leads. One solder joint, 2 solder joints, and crop the resistor leads. So that's the capacitor and discharge resistor. And now I shall make the bridge rectifier. So I'm going to get two diodes with the positive terminals, the ones the bands pointing together. I'm going to make this quite small because there's not an awful lot of space in here. And I'm going to twist them together like that. And I'm going to get two matching diodes, and I'm going to put the opposite end to the bands together, and I'm going to twist them together, and they'll be the negative. And I'm going to solder them. Just a wee tack of solder. Okay. Then I'm going to splay the diodes apart and place them together strategically like this, so that when they're just facing the correct way for twisting, because then I'm going to twist the two pairs of diodes together with the AC connections, so they'll have one band and one without a band pointing towards it. Okay, that's the AC connections twisted, so I'll give them a quick blob of solder. This light, when it's made, will have basically mains voltage on the... You have to treat it as mains voltage on the terminals. It's not something you could sell in a shop. Well, unless, of course, you live in China and you can sell anything in a shop. But so it's strictly, it's more for the novelty aspect. Now, the capacitor is going to go to one of the AC inputs, which is one of the points in the rectifier that has both a band and a non-band end pointing towards it. And I'm going to put that up like that and twist that round like that and solder it. Oh, just discrete and no circuit board around that, just because it's easier. And once that's cooled down, I shall crop that quite short this time because I want to fit it into a small area. On the other side, I'm going to have this is the mains in, so I'm going to have the current limiting resistor, the one that's designed to, the 1K resistor. It basically means that when it's powered up, if it's at the peak of the mains cycle, then the burst of current that goes through the capacitor will be limited to about 250 milliamps on our main supply. And it reduces the burst of current through the LEDs. It also acts as a fuse in case something goes horribly wrong. So I'm going to bend the positive and the negative up now and cut them short too. And that is our power supply. The capacitor, the 1 megohm discharge resistor across it, the 1K resistor, both come in from the mains through the rectifier to the AC terminals, and then the positive and negative pointing up the way, ready for the LEDs. So should I point that in right now? No, I'll leave it until I've got the rest on. But I think that, hold on, let's poke it in and see if it's going to fit. That'd be a good idea. This is where I always come a cropper trying to get the leads through. I'm also noting that the little metal pin that's used in the bayonet cap for locking it is, oh, this is not going down. Why is this not going down? Oh, there it goes. Oh yes, that's going right down in there, so that's very good. That's going to leave loads of space for LEDs. I'm noticing this metal pin that goes through for the bayonet cap is exposed in there, so I want to be very careful to keep any electrical connections away from that. But that looks fine so far. Right, I'm going to take that back out again because it's going to be easier putting it in with the LEDs afterwards. So let's get these clippings out the way. Onto the floor, in fact, where they can be vacuumed later. Now we need the stems and the sockets. So here are the sockets. They're standard little Molex style connectors. I say Molex style because they're Molex knockoffs. And what I've done here is, because one side's going to be positive, one side's going to be negative, I've decided which I want to be positive and which I want to be negative, and I've basically taken a Sharpie and just run it across and made one side black, and that's going to A, help with assembly, getting them in the correct polarity, and B, it's going to help when you're putting the LEDs in to make sure they're all in the correct sort of polarity as well, because you don't want to put the LED in the wrong way around, otherwise they will die horribly. They won't blow up or anything like that, but the LEDs will generally fail if you reverse voltage them, particularly I'm going to be using mainly gallium nitride style LEDs like this blue one, so if you put them in the wrong way around, it just kills them. Red and green, the older green ones, they usually survive, but these ones don't. So now, what I'm going to do now is I'm going to find a wire, and this wire, I'm going to cut it into sections. I'm going to put 12 lights in, because 12 always looks nicer for some reason. I mean, you can really go overboard. You could go for this completely ridiculous one I made with 50 LEDs in it, but to be honest, it's a wee bit too cluttered. You know, I thought this was going to look great, and it does look good. It's a mixture of cold white and warm white. I'll plug it in. That's the best bit. And it's nice enough, but it just looks kind of too cluttered, really. It just looks a wee bit too much in a small area. So I kind of prefer the smaller number, and that just makes it easier to build them as well. So I want to get the wire, and this wire is going to be looping like fair lights between the LEDs, like Christmas lights. So the length of the wire I'm going to cut is going to be the equivalent to 2 stems coming up. So I've marked this on my bench, and I find one of the easiest ways is to put 2 marks on the bench and then just measure the cable out between them, grip it with the snips, pull it out to the second mark, cut, and then go back and pull it out to the second mark, cut, then go back, and finally just cut the last one. It just means you can really whiz the cables off really quickly. So I'll put that wire out the way. And this is where you've got a choice. Now, I'm going to strip the wire, just a very small quantity, only about 1/8 of an inch, 3mm at the end. Doesn't have to be much. This is solid core. The reason I'm using solid core is I wanted to support the lights. I'm not 100% sure these are totally rated for solid core, but you know, it's worked so far. They're certainly not being moved around like a sort of portable connector on some sort of device that you're moving around all the time. So they're not really, I don't think it's going to give any issues. Now this tool is a crimping tool for these crimps. It's quite an expensive tool. Only really justifiable if you're going to be buying a lot, if you're going to be actually crimping a lot of these. I use them a lot in my props and stuff like that, so I do get a lot of use out of this tool. And it makes a great little crimp joint, and it grips the cable. However, if you don't have this, you have another option to use a pair of these little grips here and solder the wire in. But when you do that, make sure that the connector, the open end of it, angles down away from the springy end of the connector, so that the solder won't flow up into the connector area, because the connector is, it's kind of like, the cable comes in there and then it's folded up and then it sort of curls round like that, and it's designed to give, it's designed to move down as the pins get pushed in. And if you let solder flow down, it will actually jam the whole connector up, it won't work. So you have to stop solder, you know, coming anywhere up beyond this point here. So I've got that connector in there, and I'm just going to put a wee touch of solder into the connector by heating it, by touching the soldering iron to the back and touching the solder to the front of it where the wire's going in. And then I'll tin the wire itself, place it into that connector, and then reflow it. And when that's done, theoretically that should, if I've not splashed the solder everywhere, it should fit into one of these connectors. Let's get another one that I'm not going to be using, because this is just kind of demo. That's why I'm using 2 different techniques. Oh right, okay, I have left a splash of solder on that this side. That's alright, I can trim that. Crimping is best, but this will work as well. That's it. So it's gone in, that's the crimp one. Because it's totally crimped in, will go in easily. So that's how they go into the connectors. However, to save time, and to save you all getting bored, I have made them all in advance. Because I'm a cheat. Here we go. So, most of these, there are 13 of these because there are 12 sockets, and it's basically the 11 loops between the sockets and then the 2 tails coming out the end. So there are 11 of those loops plus 2 tails that only have a crimp on one end. And all I have to do is find the other one with that doesn't have the crimp on the other end, because I don't want to put it in the wrong socket. There it is. Now what I'm going to do is I'm going to mark one of these as being the positive, and I'm going to do that with a Sharpie. I'm just going to put a wee mark on the end of the wire like that. And then I'm going to take one of the sockets and I'm going to put it into the side that I've deemed is to be positive. And I'll take one of the loops, and then it'll start with a negative and go to the positive. And basically it's just like a string of Christmas lights in the series. And it really helps while you're doing this to keep saying out loud, really, negative to positive, negative to positive. Because if you lose track, you can stick it in the wrong one and it's a real nuisance, particularly if you don't really notice you've done it. Negative to positive, negative to, put it in the right way up, positive, negative to positive. And now you're probably realizing why this can get quite boring if you're trying to make the one I've made with 50. It was just starting, it was really unwieldy to make. And you'll also see that when I get into the next bit here. So, have I just, yeah, no, that's alright. Negative to positive, negative to positive, almost there, negative to positive, and the last one, negative to positive, and then the other tail that's going to be the negative tail. Excellente. Now we're going to go to the other end, and this time we're going to actually hold the first 2 sockets together and pull the wires down to the same length, and we're going to put a twist in them. And you'll see why I'm going to do this later. Well, basically I'm going to thread them all onto another bit of wire. So then you go to the next one and you pull them down, put a twist as well. This is the easiest way I've found of doing this. The first time I tried making one of these, it ended up very unwieldy. It ended up trying to clump them all together and wrap wires around them. This is by far the easiest method of doing this. We twist. I chose white wire because it just kind of looks quite nice. I've done one with black wire, but to be honest, the white wire looks nicest. I mean, obviously it'll depend on the colour scheme of the light you're wanting to create. You could actually even use just random colours. As long as the polarities are all kept right, it should be fine. And this is fairly generic panel connecting wire, this stuff. I'm not 100% sure what gauge it is. But it's very thin, it's just generic sort of the stuff available from electronic suppliers. I don't know if it actually says. I don't think there's a label on those reels. I should have looked at that, not to worry. It's typically rated about 1.4 amp-ish. In this case, because I'm running LEDs at very low current, it's only going to see about maybe about 5 or 10 milliamps probably. Almost there. It's one of these projects, just to take your time with it and sort of enjoy it. So starting from the other end again, I'm going to take a bit of wire, just another bit of solid core wire. In this case I'm using brown, just because it's what happened to come to hand, and feed them on in sequence, and now you can see it's going to keep them all clumped together now. And that's why the little loops there at the bottom, it's designed to actually have the wire pass through them and hold them in position. This came in very handy. It took a long time with the one with 50 lights on it, but it was surprising how when this wire was basically pulled, they were pulled tight against the wire, it actually fitted all in a very small area. I didn't initially think it was going to fit, but it did. Okay, so these are the two feed wires. They're not involved in this. So now I'll just clump them together and twist the brown wire, and that keeps them all clumped together. And then I'm going to cut it. There we go. That's our clump. Now I'm going to pull the wires straight, particularly with the two feed wires here. It's a wee bit more tricky, and twist them like this. And this is going to, it's not so, it's easier with the ones beyond. Once you get beyond the feed wire, you have to hold the feed wires because they're not already trapped in this wire. And then I'm just going to twist them together like this, and this keeps the wires together. It makes it look neater, and also it makes them stronger. This is where if you've had any problems with your soldering, the wires will probably pop out from the sockets, but it should be fine. I've never actually had one pop out of the socket there. I do tend to crimp them. If you hear the slight buzzing in the background, it's the soldering station, the Yahoo soldering station. I'm using that quite a lot now because it is quite fast to heat up, and the heat gun is great for doing heat shrink. And now the last wire. Okay, that's us got our bunch of, well, sprig of flower holders, LED holders. So now I'm going to note, this is quite important because I didn't do it the last time I made one of these. Here's the positive, so I'm just going to mark that a wee bit further up here. So there's the red mark there, and I've just marked it further up here because I'm about to cut them shorter and solder them onto this little power supply. And I'll keep the wires deliberately quite short here. Enough room to work, but I'll also some room to just fold them up out the way. And I shall solder them onto the rectifier. Let's clean that off. There we go. So I'm going to tin those, a bit of solder on them, and now the red. The positive is going to be the one with the two bands of the diodes pointing towards it. So that's one connection done. I'm trying not to burn myself. The other connection done. Okay. And that is fundamentally the circuit. Now I'm going to just double those wires over like that, just to save space. And now I'm going to try and put it into this holder. Let's see if I can get it in first time. I doubt it, but you never know. Oh, I just got it in first time, that's quite handy. Actually, that's got quite a lot of room in there, that's very impressive. Right, excellent. So I'm going to pinch the wires towards the middle. I'm going to crop them kind of flush with that and get those pins. And I'm going to push those pins in to trap the wires, which is how the connection made. The wires are a wee bit thicker. Previously it was stranded wire that was in that lamp holder there. So it's going to take a wee bit more force, and I think I might just push it hard down against the bench. That's done it. Right, now before I go any further, it would be a really good idea to test this in case it's not going to work, because I don't want to pot it in resin and then find it doesn't work. So I'm going to stick the LEDs in now. The LEDs I've prepared in advance. The long leads and the short leads I've kept it that way, but I've cropped them down so they're not going to stick right through these sockets. So the long leads denote the positive, short leads are the negative, so that the short leads will go into the black positions. So let's see if I can make a dick of myself by getting at least one of these in the wrong way round. It's so easy. They make such good LED holders. I've used these a lot in the past in prop making because it means you can actually supply just a wiring loom, and then other prop makers building the more complex visual props can then add the wiring loom in later, and it means you don't have to spend a lot of time in the workshops, because otherwise time just eats up. And then I shall plug this into the mains and see if it goes kaboom. Rightio, let's try this out and see if it goes kaboom. Nothing's really gone kaboom yet, has it? Okay, so I'll turn the light off so you can see this. That's all looking good so far. Yep, that looks fine. So now, I'm going to pot that in resin to keep it strong and support everything, and I'm going to add, and here's a clue what's coming up and why there's some small white LEDs in there. I'm going to add some of these little leaves into the resin as well. So I'm going to just support these, maybe even just tie wrap it together as a clump. In fact, I probably will do that. Then I'll resin it, and I shall be right back once that's cured. Well, that's it potted in resin now, and it's cured, so I've fanned them out a wee bit, but now it just needs that final finishing touch. The shrooms. So I'll push on the little magic mushroom caps from China. And they're going over the warm white LEDs, the warm white diffused LEDs. Where's the other one? There it is. And then we'll plug it in and admire our handiwork. Okie dokie, I should just turn the lights off again. Oh, look at that! That's actually quite nice. Now, do remember that these are these connections. If you're messing around, that they're not fully exposed, but there are electrical connections tucked in behind the LEDs that you could touch and get a shock off if you were touching something else at the same time. So just be careful. Also, if you're changing LEDs, note that if you pull one out, they'll all go out because they're in series. And as you're poking it back in, just be careful, because those wires that are exposed are live, potentially. It means voltage. Well, they are live, it means voltage. So yeah, that looks pretty good. I'm going to put that in a light fitting now. Let me see. Let's test the power of this. So I'll plug it into the power meter. It's not going to be very high. I don't think it's even going to be a watt, but we'll never know until we test it. It's not registering at all on the watt meter. Okay, that's reasonable enough. And the intensity is good for decorative purposes, and certainly in a room at night time that would cast some light around the room. So yeah, that's quite nice. That's going into one of my lampshades now in place of one of the others. And if you do try this project, do keep in mind that it is much better to keep things simple. Here's another backup room I made. And it's much easier doing something like this than this. And to be honest, when you compare the two of them, this more spread out one actually looks nicer than this one with actually the massive points. It's alright, you know, it's got its place. But this one's easier to make and will just be that much easier to build. And yeah, just remember, it is, you know, it's a mains drive power supply. It's not low voltage, so although it looks pretty, it can kill you.